Hey, everybody, this is Larry. This is. I should know what day it is. It's day 22 of the Leetcode Day Challenge. I don't know why I paused. I usually do it. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. Um, yeah, today I went 6 miles in Central Park. Not that much elevation. I think some people were asking about it. I don't mean to suggest that I'm running a trail, though. I would love to go run a trail marathon someday in my life. But I think it's kind of odd because I was talking to a buddy of mine and I just don't know because I think I would love to run a trail kind of, but the reason why it's a kind of is because I also love to go hiking and just take beautiful photos, as some of y'all might know from my Instagram. So, and I don't know, like if I have to choose one, I think I almost want to just go for photography. And in photography, you're not racing because you're trying to find the perfect light and all these things, right? In general, or as best as you can make it, of course. And that's a lot of just waiting and looking for a good opportunity. But but yeah, well, obviously, when you're running a trail race, you try to run as much as possible. So I don't know. Yeah, today is Saturday here in New York. This is day 22. The contest, the Leetcode weekly contest, is here in about 2.5 hours. Just a quick pre-word. You can skip ahead, of course, if you like. Um, yeah, I mean, I don't know. I almost let me know in the comments what you think about this, but I'm almost ready to kind of retire doing Leetcode contest. I think it's just annoying, frustrating, and it doesn't. At this point, well, I never really had much to prove, honestly. But at this point, it's just being silly, right? Like, at some point, I'm learning Leetcode Python and not like trying to express myself and problem solving. Instead of focusing on the problem solving, we're focusing on how to make Leetcode work. Uh, you know, and it's just kind of getting a little bit silly at some point, and then I'm just not having that much fun when when that's the case. I don't know, maybe not quite yet, but let me know what you think in the comments. I mean, that's the thing, right? Is that the way that the system is set up, there's no objective. That I wouldn't say there's no objectivity, but there's certainly a lot of subjectivity involved, right? In interpretation and all these things, and especially after the contest. I mean, by the admins, right? I mean, I put it in other ways, but it's subjective in that. Look, at the end of the day, they can make any problem, any solution or solutions fail if they really want to. I mean, that would probably be a little bit on the more extreme side, but there's just a lot of language that they don't care about, and not even that they don't care about it. They're very proud to say they don't care about it because what they say is just like, oh, get better, and I'm like, well, if you don't want to support it, just say you don't want to support it. This is like in between, and I don't know, maybe I'm fine with and if I really care, I could do the contest in C++ or Java, but I just don't enjoy it, right? For now. And doing it in Python easily cost me 100 or 200 rating points, just in random swings, right? Like last week, it cost me like, I don't know, 60 rating points just on one contest, like going up versus going down. And then there's all these things where, yeah, even that contest, as you might know, I did Q3 and Q4 in Java, kind of. I used ChatGPT to translate, but even that translation took like an extra 5 to 10 minutes, of penalty, right? Of me not trusting the system or not trusting them, really, penalty, right? And that's the thing, right? Is that when it is this significantly subjective, a lot of it is based on trust. And and it's not trust partially trust on the system but also trust in the admin because they're doing this after the contest, right? It's not like it's bad enough that I have to second guess the constraints, and whether they'll time out versus knowing whether they'll time out, um and memory apparently as well. Those are the two things already. We have to trust the admins, and so far I feel like they have done nothing but betrays people's trust. And also, it is my opinion that honestly, if people gave a suboptimal solution that passed, I'd rather that stand like SAC, yeah, maybe it's a little bit unfair for that one person, but that person took a risk with a weird thing, and versus like failing someone who probably should have gotten right, but your engine is just not smart enough to or not, the engine is just not robust enough to catch it, and you stick by the fact that your engine is not good enough to robust enough to catch it, and then just fail people who have to guess what your engine does, right? The Leetcode engine is silly. Like, why would it run out of memory if you clear memory between each test cases, right? Well, they don't, because they're lazy in how they implement the memory reusing, right? Which is just a little bit silly, and that kind of stuff could be easily, easily for a competent team to do it. I mean, I know maybe there's some legacy reasons, for sure, but design things are tough, and design things are tough to migrate when once you've done, made a poor decision in the beginning. But still, this is not a new thing. It's been mentioned for about 2 years, so I don't know. At a certain point, is it incompetence? Is it malicious? I mean, I don't think it's malicious, but either way, either of those things means that you just don't trust them, right? Like, it does, like, at a certain point, if it doesn't matter what the whys, you just don't trust them. So, and that's the thing, right? When you don't trust them, then like what does the rating mean? When the rating just means when the rating means even less than it did before, because if ChatGPT, people who use ChatGPT get a higher correct rate than someone who did it manually, it's a little bit silly. But in any case, okay, it's a little bit of a rant. My apologies. Let me know in comments what you think. I don't know. I'm just very I just don't care about it. That's all. But maybe I'm wrong. Maybe it makes a difference. And I would also say that in general, people don't watch those videos that much. I mean, I know a couple of people do, but not in general. Or at least they don't upload it or comment on it. So I don't know. And when they do, they say, I could have explained it better. I'm like, yeah, okay. And you could have solved the problem better or understand the problem better. What's your point? Right? In any case, okay. That's another rant that I've already done before, so I'm not going to go into again. But yeah, let me know in the comments what you think about that. Anyway, let's take a look at today's problem. Sorry for the long intro, but it is topical. It is something that, it's happening in an hour. I mean, I'm probably going to do the one in an hour, honestly, but it's just, Anyway, okay, let's take a look at today's problem. Thank you for listening to me rant, and let's go. Today we have 440, kth smallest in lexicographical order. Given two integers n and k, return the kth lexicographical small. Okay, so this is basically the same as yesterday, except we have to do it in order. The first thing to notice, of course, is that you cannot simulate. You can't just copy the code and then just cut off early, because, one is that n is very big, but also k is very big, so you can't do it in O of k or O of n. We talked about why O of n is not linear yesterday, so we'll keep to that. So this is a 2-hour video, so I kind of usually, I mean, and it is recorded live. It's just be on the later part of the video. I just kind of want to give you an intro about how this video is structured, a little, so you could kind of skip ahead in a good way. So for this problem, initially I thought it was binary search. You can go through my logic, but I end up taking about half an hour. And then after that, I was like, oh wait, this is just digit DP. And these things don't mean anything to you. I don't know what to say. But you definitely need to know dynamic programming as a prerequisite. I don't go over dynamic programming in itself too much, but digit DP I do. So basically the rest of that, the next hour or so, is me a little bit sadly knowing that it was digit DP, re-deriving everything step by step. Honestly, I think I usually go a lot faster, but this time it took an hour because I was just dealing with a lot of off by ones and stuff. But if you want the full experience, maybe watch it on 2x, with keeping in mind that maybe you have to rewind when I say something. But you can kind of see my thought process. and how I break it down to rederive digit DP, right? Because I don't think about digit DP in any special way. I just kind of break the problem down into multiple pieces, which turns out to be a template that people do, which is digit DP. But I usually just break it down in different cases. So I don't have to memorize the template, and it ended up taking a long time, but that's fine because I'm here to solve problems and not plug and play templates, right? But so if you watch that, go for it. And yeah, without further ado, that's all I have. That's what this Larry has. So thanks for watching, and hit the like button, and now you could watch the actual live portion now. Oh, one last thing is that the explanation is near the end, so definitely check that out, right? I mean, it's not a long explanation because a lot of the explanation is during the writing of it, so definitely check that out near the end. Let me know what you think, and yeah. But that means that we do actually need a linear-ish solution, right? And I say ish because it's probably gonna be base 10 or something, which I guess, you know, in a big O notation. So I keep scratching my face. I feel like, I don't know, maybe I have a pimple or something. I don't know if it shows up. I don't even know, but I think my face is just a bit itchy. In any case, yeah, so you have to do it a little bit better. So yesterday's problem, as you recall, we couldn't do any better even if we try, just because that's the size of the output, right? The size it's the size of the output. You can't do better than the size of the output because it takes at least one time to allocate the space for the size of the output. So it's gonna can't do better. But for this one, maybe there's a linear way to do it, right? So let me give it a think. I mean, okay. So I mean, the thing is that what do I want to say? I mean, we did some exploration yesterday, right? Because because we did, that was a similar but not quite problem yesterday. So the first thing I would say is that we haven't watched that video. I think I maybe is an I mean, I think I did a good job at the. I don't know if I did a good job, but I feel like I did a good job solving it. I don't know if I did a good job explaining it in the end because it took me a while. Maybe skip the beginning, but I think if you want to watch that I think that'll give you an idea of where my head is at and an intuition. Of course, you might have solved it yesterday as well, with or without looking at or watching that video. So so maybe it's just worth it, but I don't know, because I mean I'll try to I'll try to articulate thoughts that I've had, of course, but in case I forget something, then that might be because of that. Yeah, let me see. Right. Okay, so again we have this. I mean, the K doesn't, or the off by one probably doesn't matter. So here I'm trying to kind of, if my computer lets me click into this window, it's a little weird. I want to kind of just like see what's up, if you will, right? I mean, we kind of ran over how to generate them yesterday. I don't know why my computer's a little bit slow. I should have rebooted it before I started this. Probably should do it before the contest just in case. I think, I just haven't rebooted in a long time. Let me check my uptime. I don't know why it's lagging for me a little bit. Maybe I have something weird running on the background. Okay, it's up. It's been up for 3 months. I guess it's time to reboot it a little bit. Okay. Anyway, okay. I mean, I think so. So also, just to be clear, we don't have to. The tough part about yesterday's was that we had to do them in O of n time, and I kind of did it without the log n space thing, right? So so that was so that was what that was a lot of the difficulty, right? So So that means that we didn't do it the I would say, I don't know if it's not a dumb way, but it's the dumber way, right? Of just constructing it with a depth first search or something, right? So okay, so if we, I think, yeah, I think maybe it's worth doing it with no, I don't think so. I mean, I think honestly, the short answer is that my intuition is that it's going to be binary search, right? But of course, um, so all right, let me step back for a second. I was going to say that maybe we could get some intuition from generating the sequence using depth first search, but then I was like, I don't think so. Actually, I'm wrong on that one, I think. But then the second one is just binary search, and the thing with binary search is that we want to binary search for the answer, and that's a very easy thing to write. However, so what would you put in the good function, right? I mean, obviously you can't generate all numbers up to the number because then that becomes n log k, n log n or whatever it is, which is way too big for this problem. I mean, it's worse than O of n, right? So it's going to be worse, right? So we have to kind of do that in a better way. And then the question is, how do we count in a better way, right? And I think this is one of those things which is, if I have to guess, I mean, it's a complicated way, but if I have to guess, it's going to be whatchamacallit, digit dynamic programming, right? Or is it some? I don't know. People come up with all these names for dynamic programming things, and when I learned it back in the day, it was all just dynamic programming. We didn't have any funky names, fancy terms. So yeah, but I think that makes sense. I mean, so anyway, step back for a second because I know that maybe I went too fast. So the dot process is okay, and each of this I have. So what makes this problem hard is that there are multiple components, right? And I want to step back a second to kind of explain my dot process a little bit more in detail, because I think for me that's the more interesting part, right? I mean, yeah, the solution's also interesting, I suppose, but the first thing I thought is like, okay, can it be binary search, right? I mean, I think the other thing that was like, okay, I mean, I thought about other stuff, of course, but we won't go over it here for now. So I said, can it be binary search? Okay, and then I go, so then my dot, and as you practice and do more problems, you'll get better at this. It's like, my main next thing is, if it is binary search, what would we search for? And then now, if it is binary search for the answer, what is the I call it the good function. I think it's called like the satisfactory or monotonic function or whatever, but I forget what it's called exactly. But yeah, what is the good function? And then my first idea is that, okay, we cannot generate up to the mid number, the test number, if you want to call it, the target number, because it takes O of mid time, which and what happens is that it will take O of n log n in total. This is small n because that's not the size of the input, right? And then I go, okay, well, can we count the number of numbers before mid? So that's my next process, right? Can we count the number of, well, I guess technically before that is that is there a way to generate the good function in O of one time, right? Or basically O of one time, maybe O of log n time, maybe. We need this to be fast enough, right? So it has to be O of 1 or O of log n to be fast enough, because basically, if you know binary search, you're going to have like left is equal to 0, right? right is equal to, in this case, I think just n, honestly, because it could be either root. So then you're gonna write something like this, right? Right? Roughly speaking, right? And then so if middle is good enough, that means that there are enough numbers that are smaller. We want to try a smaller number, right? I think so. Otherwise, maybe I'm just wrong, but that's fine, right? So then we're going to have something like this, right? So then, yeah, we have O of log n loops or iterations, so we can make it O of log n or O of log n, right? Or times log n, yeah, log square n, if you will. Yeah, right. So then now the next, so then the only way that you can do this if you don't, if you don't generate all the numbers, right? So then if you don't generate all the numbers, what is the question? Well, can we count the number of numbers before mid, right? And I call it target, I call it mid sometimes, so please stay with me. Maybe I'm a little bit whatever. Can we count the number of numbers before mid, right? And then from that, it leads me to, I think, and this is Larry, right? Larry thinks, and I'm talking to myself in a third person. Maybe that's just weird. I don't know. But yeah, there should be a way to calculate with digit dynamic programming. Right? And then the next question you may ask is that, what would be the complexity here? To be honest, I don't really know, but the thing is that the reason why I was confident is that in general, and this is just me hand waving, right? Like we'll work through it together. Right at this point in time, as we're talking, and I haven't thought about it yet because I'm typing this out, I don't know what the complexity will be. But from experience, it'll be O of n, maybe third. I mean, like less than O of n. I guess that's like, yeah, less than O of n to the less than equal to n of third, or maybe O of n to the fourth, or at worst. But n in this case is the number of digits, right? Yeah, it's either the number of digits or maybe the number of alphabet, the size of the alphabet. And like I said, at this point, I don't know, right? But that's what I would think. Just because this part is from pure experience of writing digit DPs, right? So yeah. So in that case, that'll be fast enough. I mean, at least. So is this? If this is correct, is it good? Still, I don't know, honestly. But it is enough for me to explore how to solve this, right? So then now, so this is the idea of how I got to where we are now. And I'm getting up for a second to grab a soda. Hang on. Sorry, friends. When you talk a lot, you gotta protect the voice maker or whatever, right? Hang on. I got a giant brisk tea thing. Okay, so that's basically the idea, right? So then now we have we're good of a target. That's why I say target sometimes. And basically for this function, we want what? Count the number. This is basically what the function we have yesterday, actually, right? So oops. I'm gonna just give you like a crappy version of a good function by copy and pasting yesterday, right? Right? So this generates this, right? So this is our code from yesterday. So then now, yeah, we want to return the number of numbers smaller than or equal to target. Right? Maybe let me phrase it this way, right? So yeah, no, I think this is it. and by smaller than, what I mean is appears earlier, right? Number of numbers appearing earlier than target. Technically, it's earlier or equal to. Right. I mean that off by one is not a big deal actually, but because you can adjust it and maybe you need to later. Yeah. So I'm just gonna put this here. This is from yesterday. Sorry, let me put the notes here for y'all people. Maybe we'll, if you want to read it. But yeah, but this is the thing from yesterday. So here maybe we just have a get count, right? We have this n, and this is the thing from yesterday. But instead of returning the array, we just return the length of the array. And again, this is a very slow thing, right? Because this thing is would be this thing. We can generate. I mean, yeah, we shouldn't, but I just want to see that verify that our idea is correct. So here we return what do I call it? Get count. And this is good if this is less than or equal to k. We may be off by one because I always 0 index and 1 index stuff. It's a little hard, right? So well, this is just returning the biggest number. So maybe I just signed wrong. Let me think about this again, right? So if no, I got the signs wrong. Okay. Well, okay. I mean, you could do it this way as well, but then I have this. It doesn't make sense here. Okay, so that means that no, I like it the other way actually. Okay, so I was wrong. Well, it also isn't true that we return the number, but what we know is that yeah, if the number is am I just off by one or is it yeah, wait, give me a second. these off by ones are always a little bit tricky for me, but okay, so if these are the numbers given a target, so that means that if we have greater than or equal to k, then we want to try a smaller one. So this is right, I think, right? I mean, we should audit our stuff. So here mid, let's do a calculation here. Now, let's do get count mid is what I want actually. Okay, so 6 ref 6. This is clearly wrong. Oh no. Oh, I see. Well, this isn't. Yeah, this generation is not right because we want to generate not the target. We want to generate up to n. Yeah, I see why. Because we want to generate up to n, but we want to get the number of numbers that are smaller than it, right? Or equal to before it of this number. So then now we return get count n of target, say, right? So then now we have n and we have a target, and then just in a lazy way we can do like enter dot index of target, something like that, right? Get count. Oh, little sloppy on my hand. Oh, this should be the small n. Okay. 0 is not in list because we don't do it. Okay, whatever. Yeah. This should have been this anyway. Okay. So at least these now make more sense. So 7 is the 10th number. Is that right? So this is 5. Okay, so 10 numbers are smaller than it. So yeah, so this is the 11th number, so I think we need to add one here. Okay, so now, well, so 11, this is the number of numbers that are that number or smaller. If it's greater than or equal to k, so then it gets smaller, smaller. Oh, I'm doing it wrong. Now this is, I think the way that I'm doing it is wrong. Or this is wrong. Like I said, there is some risk in it being wrong, so, and I guess this is one of those cases. The reason this is wrong is because I got confused, I think, at some point. And what I mean by that is that the reason we're wrong is because the 2 basically, yeah, you never search for 13 or whatever, because it's wrong. It's wrong. The reason it's wrong is because I'm just being a dumbo. Maybe it's just digit DP. Honestly, maybe not the binary search. The binary search is definitely wrong though. Maybe. Hopefully, I get the bad practice out of the way. You know what they say? You better have a bad practice than a bad test, right? Or bad race or bad whatever. Yeah, the reason this is wrong is because if you kind of put, you know, if you have, oops, let me put it a little bit farther away. If you have like an x graph, right, from 1, 2, 3, 4, 5, and then this is f of x, which is maybe the location of x, right? So 1, 1, but then the next number is going to be 10. So then 2 is actually in this case, okay, let me find it. So 10 is going to be 2. So 11 is going to be next, then 12, then 13, and we only have 13 numbers. So 2 is going to be here, and then 3 is going to be here. So then now this graph actually kind of looks like this. And then it drops down, if you will, and then go back up, right? And of course, this is not binary searchable, right? I mean, hopefully this makes sense now that I draw it out. I drew it out way terribly. So, yeah. I think I just confused myself a little bit with the binary search. So, we spent a lot of time. My apologies. I mean, that's the risk of doing these live, is that some days you look like an idiot. And today I am that idiot. But yeah, but I would say though, then it's probably digit DP. So I mean, we look at all this, and yeah, I'm a little bit disappointed in myself, but that's okay. That's part of the exploration. Okay, so that, yeah, we don't need that anymore. We don't need that anymore because it's wrong, right? And now, yeah. So can it be binary search? The answer is no, because I think I was going it the other way for some reason, but I don't know. No, because it is not a monotonic function, as you saw. Yeah. But then bam. Sorry, friends. At least not like that. So okay. So then now, how would we solve it? All right, half an hour later, we're trying to solve it. I mean, I think it's gonna be digit DP then, because I was thinking along those lines anyway. But I mean, I think basically the idea is that, okay, you ask yourself, can you increment? And that's really it. And you do a digit at a time. So maybe you don't even need, I don't even know if it's digit DP then, right? But some of the idea, right? So what I mean by that is that we just kind of keep track of a prefix thing, right? So, okay. So let's say we have n is equal to 13 in this case. And then now we start at 1. Okay, yeah. Okay, we start at 1, right? And then now we go to 2. Well, okay, so okay, maybe let me restart. Let me restart. Sorry, it's not a new idea per se, but it's like it's hard to reset the brain, and you saw me kind of mess up for so long. But yeah, basically the idea is that, okay, what is the first digit, right? So we do, it may end up being digit DP, it may not, but it has a digit idea, which is that what is the first digit? Okay, if the first digit is 1, then right, can the first digit be 1? Can the second digit be the first digit be 2? ... Right? And the way you kind of check this is by the way that you check this, and maybe end up being digit DP anyway, is that you count the number of things that begins with 1 but before 2, right? Something like that, right? In this case, you would say, okay, well, can it be a 1? Well, there'll be 5 numbers where the first digit is 1. So then, and k is 2. So then that means that the first digit has to be 1, right? If k is, say, 10, then, well, now at 5 characters or 5 numbers later, so it cannot be 1. And then in this case, there's only 1 number with first digit 2. So, but it's still no, and then you kind of count down kind of thing, right? And then the question then is, how do you do that count? And this may be where the digit DP comes from. Today I'm just so bad. Hopefully I got the badness out of the way. So how do you count that? How many numbers begin with 1 in this case? And the idea here is that you want to do it somewhat recursively, right? So here, you have this. So then, okay, can the first digit be 1? How many numbers have first digit be, with 1 at the first digit, right? Well, that is just saying recursively how many numbers are there with 1 0. How many numbers are there with 1 1? I mean, maybe not even yet, right? It's recursive. So how many numbers are there with 100 and so on? So that's basically the premise for digit DP. So I think this is digit DP then, right? So yeah, so I think that's basically the idea. So then now we help ourselves kind of with these functions. I know that there's a template that people usually do, and I don't do it. I do end up proving it every time anyway. So I don't know, because I think of it as a more intuitive way. I would also say that for this video, we will not be going over dynamic programming in super detail. So if you want to just, we'll go over how I come up with the digit DP part, but not the details about dynamic programming itself, like why do you how do you do the memorization and stuff, because that's just a little bit there's enough to go over. Okay, so then now here and the way that I write it is really the way that I phrase it here, right? Is that okay. So that it's just about translating what I write to code. I don't know why there's like a little thing here. So then for F, maybe as the first digit in range of 1 to 10, because 1 to 9, right? So then now we go so this is like a prefix something, right? So yeah, so if let's say first, so I could do if f of first, if count plus f of first is greater than equal to k, this is the first digit, right? Otherwise we just add it. Now we'll put a pass here for now, right? To figure out what we want to do. I mean, that sounds right. Okay, yeah, fine. I don't know. I'm just way not smart these days. But for now, we'll just do this way. So then now we have f of, and this returns how many numbers are there with first as the first digit, right? Well, in this case, it actually is a little bit easier, right? Because n is, yeah, given this n, it's, I think it's not that bad. Am I wrong? Try to think through the cases. Okay, so for 13, it would just go up. So yeah, it is just, so okay. So yeah, I mean, there are different ways to do it, but I think the tricky thing is, and I'm just a little bit out of practice on it, but you can say, okay, how many one-digit numbers are there of first, right? Well, the answer is yeah. So then, if first is okay, so then let me do a count loop. Maybe I have something like while first is less than or equal to n or something, then count equals to, okay, right? Because basically the idea is that the first digit, I have to think it for a little bit. So okay, so if it's less than n, then it would have it, and yeah, okay. The only tricky thing that I'm thinking about is like the prefix being correct, right? Because basically, I mean, you could work it out manually. Sorry that I'm not being articulate about it, but basically, for example, if n is equal to I don't know, 25, then now for one digit, how many numbers are there beginning with 1, right? So first is equal to 1, then we just have 1, right? And then now we do 2 digits, right? 1, the answer is 1, right? If digits is equal to 2, then we should have 10, right? Because we have 10, 11, 12, 13, you know, all the way to 19. So that's fine, right? And then of course, when digits is equal to 3, we're done, right? But the tricky thing is that, okay, well, first is equal to 2, then digits is equal to 1, the answer is going to be 1, but digits is equal to 2, that is actually not the thing, right? So yeah, so maybe I have to do something like, okay, so digits is equal to 1, so we do count of power of 10 to the digits minus 1, and then yeah, first we multiply by 10, or maybe just n. We shouldn't do that, but yeah, maybe, or at least not without the number. I mean, it's the same either way, I think, but no, that's not true because you lose digits. Okay, no, okay, maybe that's fine. Yeah, then now first times 10 and then that should be ideally right. But the thing is that, like I said, so here we actually want to do this, or min of n minus first, I think should be good, right? It's either this or plus 1, because basically for 25 we have 0 to 5, so that's 6. So yeah, okay, so something like this, right? Yeah, and now I want to just play around with this idea. Okay, I didn't print anything, so yeah, so maybe we did it twice, which we can cache in an easy way, but that's not a big deal. We'll do it a third time even. Right. This is wrong. One obviously has 5 numbers, but why is this wrong? Why are you wrong? This should, oh, I don't increment. Dummy. Okay, there you go. So then now, so now we know what the first digit is, right? So then maybe we can even print first, oops. Right. Oh, well, yeah, I think I have to break, otherwise, yeah. Okay. And then now then, we know that this is going to be first digit. Then now we just ask ourselves, the two ways to do it. I don't even know if you need digit DP. You can maybe just math it out, because then now, okay, one is maybe a poor example, but maybe we have, say, I don't know, 25, and we want, I don't know, 10, right? And I'm actually going to use yesterday's code so that I could, you know, just kind of look at what 25 generates. 25. So here, if we do, what did I say? 10. 10 will still be here. So maybe we want 20, right? Then what do we have? The first 4 is the first digit. Is that true? I mean, it looks roughly right? Because there's 6 numbers here. 6 plus 10 plus 2 is 18. 19, 20. So that should be right, actually, right? What that means is that, though, first is the first digit, but we can also minus count on the k, because then now we're now looking for the new k is going to be that's right, new k, right? Auto string things are confusing me. Yeah. So okay, so the new one is because then now we want the first number in the new thing, right? I may be off by 1 here, honestly, because actually I don't know. 6. What did I say? This is 11 plus 7 is 19. 20. So 20th number is actually 3. So yeah, so I think this is maybe off by 1, but that's also fine, I think. I have a thing here. But yeah, 3 is the first number. I think that's right. And here, yeah. And now, okay, then now we have to try to figure out what the second digit is, right? And then now, what is the subproblem? The subproblem is that now we have the first digit is k, but that the difference is that now the difference is that now the first digit could be a 0, right? So then maybe now we go, okay, we know that the first digit is ding. So there are really two cases, right? One is that n doesn't affect it, and the other is n affects it, right? So yeah. So if okay, so we know that first is the first digit. Sorry, I'm like really slow today. Yeah, and it's not only that, right? Because we actually don't need. We should also know how many digits there are, and this would actually give it to us. But I think that's actually mostly it. Maybe. Am I wrong? Oh no, you have to do it because, well, you have to do it recursively in the case that n is the prefix of stuff. That's how people do normal DP anyway. How do I phrase it? Okay, so the idea now then, right, is there are two cases, right? And the two cases are kind of what I was. Okay. Oh, here. I have so many places. Right. Okay. Let's remove this for a second, or forever. In this case, right, if you have 25, and we have like this thing, then it matters, right? Because basically, let's say yeah, we're looking for 2. Let's do another one, right? Let's say we have n is 0 to 4, 5, 6. First digit is 4. This gives us a different thing than if the first digit is, say, 3, right? If the first digit is 3, then we know that every number is possible, right? Every number with a prefix 3 is possible, or that we generate every number. But here with 4, it's actually not quite right? Because, okay, let's actually choose a different number, like 412, which is still true for this one. But for first is 4, that means that 4 is possible, 40 is possible, 400, 401, I mean, sure, but dot it, and then 41, dot it, right? Oh, no, 411, 412, right? And actually, I'm also missing some numbers in between, which is 41, for example, but also 43, 44, 45, 46, dot, right? All the way to 49, I guess. So that's basically the idea. And because of this prefix, not all numbers are possible, right? And what I mean by that is that, okay, well, I mean, if you look at 412, it's, that's fine. But let's say you want to look at, say, like if your k is, say, would take you to 45, there's actually no 440, right? 440 is not in the set before, so you have to account for that. And this is where you see the stuff with the digit DP with the prefix and stuff, right? Usually I'm faster. I don't know why today I'm just so struggling. My brain isn't working. Maybe I should skip the contest anyway. But yeah. And how do we check that, right? So and just in case we didn't go over this, it's basically the prefix sum of how many numbers are smaller than it, and it's almost like a pigeonhole thing, right? Of like, okay, well, if we're looking for the 10th number and 8 numbers are in the first one, you know, bucket it, right? So you can kind of think of like, okay, let me draw it out real quick, because I think I didn't explain that part enough, and I hand waved it. This is the old thing, right? And I wasted half an hour on binary search. I thought it was it, honestly, but you know, sometimes it's wrong, and that's fine as long as you refresh. But yeah, but what I'm saying is that, okay, let's say we have some k that you know, given all this, or you know, this is the entire n numbers, and maybe you can write it so that you know, these numbers begin with 1. Or let's say k is here, right? These numbers with 1, these numbers are 2, and you know, maybe these numbers are 3. It doesn't really make sense this way, but let's say we have this, right? So these numbers are 4 with the first digit. So that's basically the idea, is that, okay, well, if you kind of subtract out these numbers, then the new k is just going to be you know, this is your new area that you're searching with k with 3 as the prefix, right? And then now if you kind of subtract that out and you kind of expand this part up out here, then now you have like, okay, well, we have a 3 prefix, you're looking for k in here somewhere, and then now you just count out all the zeros, count 1s, 2s, 3s, and then you kind of just find that bucket and then keep going, drilling in one step at a time. And yeah, like I said, it's going to be digit dynamic programming though. Yeah, I mean, but the idea is basically what I'm presenting to you, and I'm just doing it way poorly, honestly. But yeah, okay, so then k, this is the first digit. How do I write it such that oh, n, that's why I confused n with k. So yeah, so we have a string n is equal, let's say sn for string n, right? So if first is equal to int of the first digit, if this is the first digit, then we have to do something a little bit whatever, we have to do a little bit specialized. Otherwise, let's pass this for a second. If it's not, right, then we can this is the every number is possible thing, right? Because every number starting with a 3 is possible in this universe. So yeah, and also just to be clear, you can also go with 5, right? 5, every number with a prefix of 5 is possible that we can generate, right? Because yeah, because it goes 5, 50. I mean, it won't be 500, but you know, it also ends at 500, so it goes to 59. So every possible, every number that has a prefix of 5 is already possible. So yeah, that we have it in our counting system, like this one, I guess. So okay, so every number is possible. This should be easy. So then now we just return maybe I don't know, I forget how to name things, but just get every, I don't know, of yeah. So the first number, the first digit is going to be, so whatever, first, just pass it in, I guess. I was trying to be a little bit fancy. And then we have the new k, and that's really it, maybe, don't know. Right, so now we have another function, right? Get every, we have the first digit, and k. I guess we do need the first digit, actually. So then now we kind of generate them like, yes, like before, right? So then now we write another loop, right, for current, so the new digit, and maybe, yeah, okay, that's fine. In range of from 0 now, right? Because 0 can be the current number. Okay. Oh yeah, every number is possible, so we just try to get the kth number. So then now, yeah, we just count whether, um, hmm. And I am struggling today. How do I want to count it? So we want to get the kth number. And we want to basically get one digit at a time, right? So this is the second digit. And for the second digit, what do we want? I mean, okay, so if k is equal to 0, then we just return first because that's the number. And now, that's okay. Yeah. No, that's right. I got confused about number. Okay, so that means that there's only one digit. Otherwise, then now, yeah, we count what happens if it's the second digit is 0. That's why. Okay, second or current digit is current, right? Yeah, and then now we go how many things, for example, if first is 1, then how many with 1 0, and the first digit actually doesn't matter, right? Because we know that every possibility is correct as long as it's less than n. I think I'm setting this really poorly, honestly. How am I doing? Okay, no, I'm trying to reset a little bit because I think even though every 3 is possible, but 300 is in it, right? So here we have 3, 30, 300, 301, 302, dot dot dot, right? So every number of prefix of 3 is possible is not quite the same. We have to count the number of maximum digits. I think that's the part that I missed. And here there's 2 digits left, right? Okay, so then it's here, and then it is length of Sn minus 1 that is left. So then maybe now we have digits left, and now maybe we're a little bit better. Okay, so if k is 0, 0, we return first. This is the max number of digit, right? So then now, if it is a 0, right, then we go, okay, well, get every first times 10 plus current. The new k, no, we don't need a new. I mean, like, we just need another count thing, but this doesn't make sense. And because we have to do that for all the prefix, then that is going to be very wrong very soon. No, you dummy. This math is easy. Yeah. No, you don't need a. It's not a recursion yet. Not here. The number of count is just so maybe we have a helper count function of with yeah, because every number is possible. So then you just have digits, and every digit has the same. which is going to be okay. Yeah. Okay. So each number, each prefix, maybe, is equal to. Okay. So you have, let's just say 0, and then you have for each digit left. Because now with how many? So if for a given prefix, let's say with 0, how many 2-digit zeros are there? With 1, right? How many 3 digits there? 10. So you do this thing idea, and I am dumb. Yeah. Yeah. Okay. I mean, I'm writing this in a weird way, but whatever. Right. Is this inclusive? So you have 2 digits left, so you do 0 and 1. I think that's fine. Except for I don't need this then. Right. So then, okay. So then now we go. Okay. Right. Let's say we have some prefix, right? And then we okay. Yeah. Okay. And then we just do the same idea. I'm really slow today. But you know, like this is why you need to practice. So each prefix is greater than or equal to the new k. Then this is the next digit. So then we return something, right? We want to return get every well, we want to do k. We want to subtract count. So here we have k minus count. The first, now I guess we can do this because this is just an iteration and I'm just doing a lazy, right? Okay. I think this is actually right, except for obviously here. We'll take a look at playing around. Okay, actually I guess we'll just run it real quick. Memory limit exceeded. Oh, I don't have a base case, of course. If digits left is equal to, no, it should be k is equal to 0, right? Count plus, oh, I don't keep track of let's just do this and then we'll see. Should be right. Okay, well, maybe not. K is negative. Why is k negative? Count each prefix. If this is greater than k, then we should go, right? Then why is it digits left. I mean, digits left should be 0, but I mean, k should not be negative anyway. So we already, so I think this is wrong because we do this thing, but why? Maybe just for this problem, but count is 5. Oh, we don't. No, we should subtract this. Count is 0. We add it. If it's greater than k, then we. Otherwise, right? So bad at it. Okay, well, yeah. So count is 5, which makes it too big. So k was 1 before. F of first is, what was count before? Alright, let's do it before you add. Okay, so then you have count f of 5. Do I not? Oh, I just don't return, that's why. I mean, here I pass, that's why. So I am Dumbo. So return -1. Okay. Whoops. I'm returning none somewhere. Basically here, really. Let me double check if it is. Yep. Why is that? I should have enough digits, right? Print count K. Honestly, getting a little tired, but okay. Count K 0, 1. Why? First K digits left, count and K, I guess. Okay, so first is 30, K is 1. We have we need 0 digits left. Is my K wrong? Okay, so we have 3. This is the one with the 1 digit. Is it? Length of SN. It is just the maximum number of digits. It's not this one. The number of digits left. Number of digits left is wrong. So basically, if it's bigger than, yeah, okay. If the first, okay, so if there's actually 2 cases. If first is less than int of SN of 0, then now you have this thing because we took off the first digit. But then else, which is first is greater than int of SN of 0, I think you lose yet 1 more digit. Because basically that's this case, right? And if you because the max digit is going to be length of this. No, wait, -2 because you took off the first digit, right? So okay, yeah. So that's why that was wrong. But okay, so then now first K digits left. Okay, yeah. No, but what? Count is 0. So 3 digits left is 0, but why is K 1? Did I do an off by onesies? If this is Leetcode 2, then you don't. Okay, maybe. I think that sounds right, actually. Okay. Whew, all that work, and we basically have the structure, right? And we have it in English. This should be right, maybe. What's another case for this one? So 25, 20, 10, 20, 15 or 16 because I just typed it. Okay, well, that's a little bit sad. Okay, so 1. So we have first 2 digits, K digits left. Why is K always just 1? Oh, because of this thing. I made the same mistake there. Okay. Yeah, okay. I mean, maybe we're off by 1, but I think in theory we're right-ish. Why is this off by 1 though? It's gonna and the 2 is, oh, because 2 is, it matches the prefix. That's why this is just -1 because it goes here. Okay, fine. But do I want 19 to be right or the 4 to be right? Right? One of these is wrong. Let's see. We have an hour. This video has been an hour, but we also have an hour before the contest, which I know that I don't usually interrupt it, but obviously I would for that one. So yeah. Okay, so here I'm just trying to trace. Did I delete? No. Why is it not putting more stuff? Or maybe it is. Okay, so yeah, for n is equal to 13, for 25. I just have everything is 25, I think that's why. But okay. So 1, the 11 numbers with 1 prefix, that's right. 25, the 7 number with, that's not right, right? No, because it's 25, so that's what's wrong, is that there's only 6 numbers. Okay. Okay, I mean, that's reasonable, maybe fixable. So we have n minus first plus 1. N minus first plus 1. First is 20, right? So 25 minus... no, this should... Oh, wait, is 7 right? 7 is right. No, 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 no. No, 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 7 is right. 7 is right. My fault. Larry, trust your math. Okay, so then all this is right. So then you have 18, 19, and then the last number is 4. So that should be good, right? But then now the 19 number is wrong. 19 is what? We have this 10th number. The 10th number is 19. Okay, so why do you think this is wrong? At least the assertion forces, so that's good. But yeah, so 191 because we have one first digit is 9, and then digits left is 1. Is digits left 1? This is, maybe this stuff is wrong. Is digits left 1? Oh no, K is 9. Okay, no, this is right. Then you have this thing, right? And then so this is digits left. K is 9. So this, that means that we want the 10th number. I know what we're doing wrong, but basically I'm doing this, which subtracts a number. Yeah, okay. Okay, no, so that's good. That's basically the only difference. Okay, yeah. I mean, my apologies for being really bad. But yeah, so we subtract 1 for, this is a single digit of first, right? Meaning that we don't use a digit here, and this is using a digit here. And as you can see, this should, I think, get us everything. The only thing is that, okay, we have this prefix thing we have to count, which is, you know, not easy. And here we can also, I don't think you need to. But keeping in mind that we actually, yeah, I mean, we return first here, but if we rewrite this in a cleaner way, we actually, yeah, I mean, well, this can also be done with a for loop, right? But you can maybe cache this if you like. I don't, well, I mean, it's just one at a time, so I don't think it matters. Because we don't do that many. But this part, so then now we have to handle this part where the prefix is this, and we have to calculate. Okay, so then now we go get under, maybe, I don't know how you call it. So we have the first, we have K, we have digits left, maybe. Same idea, right? First is the prefix, right? We might have to structure it a little bit differently because right now we're returning first, which makes it really hard to memorize. We actually probably only need the last. Well, okay, we'll go over it. I think we only need the last digit. Well, if it's get under. Okay, well, let's see. Length of SN minus 1 because we have the first digit. But we actually don't need first, right? Because the first is implied because get under means that the first some digits is already used, right? It is exactly the same as n, which is why we have this function, right? And in this case, we don't even use first. We only use first to return it. So we maybe we'll have to clean this up a little bit to make it DPable, because I think we're going to end up using this. But that's basically the idea, right? Yeah. And then now, okay, so then we get under for k. Yeah, I think here we can actually write it as something else. Okay, let's focus on this part first, and then, you know, I'm running a little bit crazy. But yeah, okay, so that's why we have this prefix, and maybe I'll just have p for the number. I know that is actually implicit of the digits left, so it doesn't cost extra time or space, but well, a little bit more space. But yeah, digits used or prefix used. And in this case, we want to just add a 0 here. Just make it a little bit easier to keep track. So the SN of the digits used, right? So then now, again, if k is equal to 0, then we're done, right? Because that's just exactly the prefix we use. So then it's like something like, you know, something like this. 0, maybe +1 actually, right? And then now we subtract because the prefix was used, right? Because when you generate a sequence, the first number is going to be the prefix. Like if you have 413 and you use 2 digits, that means that, yeah, the first number is going to be 41, right? So that's basically the idea. And then now, as you can see though, I mean, it's not easy for sure, but a lot of it is case analysis. That's what I'm doing, and a lot of the cases kind of generalizes a little bit, which is why people have templates, but it's not necessary per se. So I don't know, just something to say. But yeah. Okay, yeah, I'm getting distracted because I want to fix this a little bit, but that's fine, right? So, okay. So prefix is used, otherwise then again it's the same thing, same idea, right? And then now, the count is equal to 0, and then the question is, okay, right, if, and this idea is actually very similar to this idea now, right? Because then now, if I meant to do this in comments in English. If current digit is less than, then every possible suffix is possible, right? What that means is that, okay, let's say if your n is equal to I don't know, again 4135, I just added a couple more digits, right? And you're currently at 412, well, then everything XX, all the numbers are possible, so you just could count them very easily. And in fact, the way that you count them is by doing get every, right? So that's basically the idea, right? And yeah, and everything with that prefix is possible. So that's, yeah. So then now we go same idea as we had before. So if count plus get every, it's a little bit awkward, but it actually doesn't even matter because the first doesn't even really come into play, as we'll see in a second, because every digit is possible. And again, we don't use first except for to return, which we'll clean up in a sec. Well, actually, get every gives you the number. So this is actually wrong. Well, not wrong, but different thing, right? because this gives us a number, not the count of those of the numbers, which is just this thing actually, right? So actually we can just actually we could just do it here. I think, yeah, this is every prefix. I think I'm writing this wrong, honestly. I mean, the idea is mostly right, but it's not right. I'm so sloppy today. But yeah, but basically, I mean, it's just the number of digits left, right? So we can actually write a different function, right? So then here we get every or get count or digit or whatever of digits left, right? And then now it's just if digits left is equal to 0, we return 0, I think. Yeah. And then it's just return get count or digits left minus 1 plus if we have, yeah, it's something like power of 10 to the digits left minus 1, right? So I think it's this, and here now you could cache it as well. It's not, it's like just a lot of ones, but yeah. And then now yeah, I think I'm confusing two things of getting count and getting the solution. So I already have this code. I think my code is just going to be ugly as hey. So yeah, so each prefix now we can just rewrite this as yeah, I mean it's memorized anyway, so but either way, right? Oh yeah, we're gonna memorize this because yeah. And then now okay, yeah, I think we're still Gucci. Maybe. Yeah. No, I think we're okay. Okay. Right. So then now, if the current digit is less than, then every possible is possible. Right? So then we can get count all digits of digits left minus 1 because this is the current digit, and this only is true if int of sn of digits used is less than current, I think, or current is less than this side, and this is the k, and this is greater than yeah, maybe I'll just write it this way because it's a little bit easier. So if this is greater than k, right, then yeah, then this digit is it, and then we just get every, so then now we can return get every first is just going to be wrong, but actually I mean I guess it's just a prefix, right? So then that means that it's int of the prefix of digits used plus 1 and k, we want k to subtract by count, and then digits left is we took 1 digit, so it's just digits left minus 1, right? Okay, so then now the other case is if current is greater than the digit, right? Oh, and if this is not the case, then we just kind of do the count we added by this thing, right, to get to the next digit. I think my code is just a mess, so it's probably not good for teaching. But anyway, yeah, and then now we just think through the case, right? What if it's this case? Well, if this is the case, then we only have one digit of freedom, so that's why this is going to be mostly the same, except for this is going to be -2, right? I have to double check whether this could be negative, I guess. What does this mean? So so if we have 3 8 then that means that none of it is possible. Okay, so maybe I just do this. Should be fine. Yeah, okay. No, I think this is fine. This is very awkward though, if this is the case, because then it just doesn't subtract anything. I don't know how that would work in that case. But yeah, and then now we have, yeah, that -2, and I think that's fine. And then the recursive case is else. So this is if current is equal to right? Then now we have another prefix that is the same. Then basically we want to return get under digits used +1. We're going to have a new k, right? And then digits left -1, right? And that's basically it. Maybe we have an assert force here. I don't know. I think this is roughly right. We're probably going to do some funky things like, you know, like we have here. Digits used. So that means that we're doing infinity stuff. That's why that means, but k should always decrease. That's why I don't know. I mean, if nothing else here, but yeah, goes out of range before. Okay, well, digits left is. What does that mean? Oh, well, I guess this, but k is 2, we use 1 digit. What is the input case for that one? Is it one of these? No, that's right. That's very wrong. What is the G? I don't need this anymore, I don't think. I think that's right. Okay, so here, digits left is 13 is definitely wrong, so maybe I just did something wrong. Oh wait, no, that's not it. Yeah, okay. So digits left is 1, digit used is 0. Digit used as 0 is wrong, maybe. No, we have to, I mean, okay, this is actually imprecise. So we actually want to stop by 1. It doesn't actually make sense otherwise. Yeah, okay, I think that is more reasonable. I think I just have an off by 1 then. Okay, I mean, it's still wrong, but at least it's better. K is 0 is good. At least it's doing some, it's not doing recursion and stuff. But so shouldn't the first one be 0? So current, this is going to be current is 0, the digit is 3. Yeah, digit use is 3. So then now this is count. Digits left is 1, so this is 0. Should it be 1? Maybe I have this wrong. Digits left. If there's one digit left, it's going to be 1. No, so this is right, but is this right? So we have 0. We used 1 digit. We have 1 digit left. Count get all digits with 1. This should return a 1 for 1 digit left. But we don't count the current number as one of them. So this should always have a decrement of 1. Okay, fine. Or even just this, I think is fine. I think this is fine, but I want to say this, but I'm not quite sure on this one actually. Get every Okay, still wrong. Okay, so now we have, because it does count the current digit, which is fine. But if it's smaller, then it's just the number of things that 1 digit. So, oh yeah, okay. This makes sense because yeah, I need to count the current digit and this as well. Okay, but then now k is 0. So why is this not working? So yeah, this should be right, maybe. Okay, so that does go here. So new k, and then we have to do, it does a get every with this prefix, which is very awkward anyway, but let's see. So we have 13 as the prefix, what? Oh no, this no, Larry. That's why you're dumb. Now this is because we want current as the digit, so we actually want, so get every times 10 plus current. Okay. Yes. I see that I'm an idiot. Yeah, that's why people have templates for these things. But I need it here as well. All right. I mean, these are easy cases relatively, so we'll see. With the 20. So that looks good, which is actually surprising. It's such grind work. And let's do 200, 3. I guess we can just, it's a lot of digits. Maybe that's 2, no, that's fine. Okay, I mean, now I'm confident, obviously, because these are like a lot, I'm just banging random numbers, right? So it could really, I mean, maybe we still have some silly mistakes, but I'm just going to YOLO submit. Apparently, I've done it before. Okay, I mean, we have some cases of, I mean, I could see why, but I thought with k is equal to 0, the prefix was used. I mean, you know, silly mistake will happen, but we'll see. 3, 6, and 0. So that's really wrong. So something is not subtracting, right? So we have the first number is 8. 1 to 10. Right, so what would it look like anyway? So we have 1, 10, 100, 101, 102. So it's going to be like 108 or something, right? Something like that, maybe 107. I don't know, whatever, off by 1. Okay. And we have k is equal to 10, so we have 1. We use 1 digit, which is the 1. So we have 8 numbers left. And then we have the prefix, which is here. So maybe something as well. Is this plus 1? Digits plus 1, okay. I don't think so, but let's see. Yeah, I don't think so. But it didn't make sense to me. Okay, 2 is a 1, 0. So we use 2. And then on the third one though, why is that? So, okay, because it goes to here every time. So that means that it only took off 1. Okay, it makes sense. After 1 and then after 2, now we want the 7th number here. Oh, oops. 7th number of this, right? So the prefix digits used is wrong. Am I confusing myself? I mean, probably. So 1, 0. So the first is going to be a 1. Okay, fine. Next is going to be a 0. Okay, fine. Oh, I mean, this has to have a thing, right? Oh, I'm dumb. I mean, I basically I just have to apply this thing, right? So, yeah, you can't just return this, but that's hard, right? Because then now we have to get the count again, which we didn't do. Because we basically try to get the k of this thing, right? So then now, so we want, I see why we're wrong, but I actually missed something. Basically, we want something like if get, something like get count prefix or something of digits used. I don't think we need. Yeah, maybe something like this is, and then we do something like this. Otherwise, count, we add this thing, and this thing we have to solve. I think I wrote it in a bad way that I have to write 2 of these. I think there was a way to not need to write both of these, like this one and that one. So then now we have this thing, right? So then now we have get count prefix, digits used, digits left, right? So how many counts are there? So basically we have say 4, 1. Okay, the way that I think about it is that I always put real numbers in it, so that's why I'm always generating. So okay, so let's say n is equal to, I don't know, whatever, 4 and 5, 6. Maybe add another digit, and then digits used is going to be, I don't know, 415. So that's going to be a 3 for 3 prefix. How many, and the 3 digits left? What does that mean, right? How many numbers are there left? Yeah, and then so then it's just another for loop, right? Of okay, count is equal to 0, and then it's just if current is right? This is basically the same logic we have here, just to be, in case you're wondering. I wrote this in a very funky way though. But yeah, get count or digits of digits left, right? Else if current is greater than this, then we add it to this -1, same logic as before. Else then it's going to be recursive, right? Get count prefix of digits used +1, one more digits prefix left, -1, then we just return count, right? Pretty straightforward right now. And with all this in mind, actually everything could be cleaned up, though, you know, this is a struggle. But yeah, if digits left is equal to 0, then we return 0, or maybe 1. Yeah, okay, I think this is a 1 actually. Okay, still wrong, but at least it doesn't time out. Because I think this is this +1, because this is for, or actually I think it's, where is this? I think there's a +1 here instead. Well, this isn't quite. Basically, it is the same as going 1 digit. I want to say maybe +1 here, but I don't know this is right. And in that case, I need a +1 here. But the reason why I think there's a +1 is because you need to get the exact digit of prefix. And if you do, then you don't need to recurse in theory, right? And that kind of trickles down. I don't know if this is right, honestly. I mean, it's an educated guess, but I don't know if it's right. And apparently I guess this factors in the +1 now. Yeah, I think this, no, that doesn't make sense. You have to be consistent. That doesn't make sense. Something is missing a 1. Does this work? No, this is off by 2, maybe because of the number of digits. So I don't think there's like a 1 here. Maybe this already gets factored in. Yeah, I guess this already gets factored in, so I don't need to recount it, maybe. Alright, let's give it a try. I mean, it works for these two numbers, which is okay, but okay. Yeah, I mean, I think honestly there is a easier way to if you skip to the end, I don't blame you. There is a easier way to learn digit DP, but basically what you did is watch me rederive everything, really. So yeah, but you can see me break it down, and you know, it basically becomes the like I said, a derivation of the DP, right? And you can write, and a lot of people put in a template and put in one way of doing it, but yeah, it's way easier to get. And I forgot this part, but I was like, I feel like I'm missing a recursion thing. And the reason why these things don't need to be cached is because if you look at it, it just kind of takes one digit at a time and then goes to one node. Like it's like a fancy for loop, because digits left gets -1 or -2 every time, so you're trimming digits every time, so it only grows the number of digits, and the number of digits is like almost 10, right? So it's not a big deal. So yeah, so that's why you don't need to memorize it, even though it's very funky the way that I end up writing it. I think the way to write this without but you need to, if you do the one with the K, I guess it doesn't matter how you write this part. I think you could written it outside, like you could get the get return value, and then outside of it you like plus whatever, right? And then here I think this actually ends up being enough. Maybe not. Is that not right? oh, now then I'm shifting and adding the other way. So you need to do like some, okay. But I think there's something like that that you can do though, but yeah, either way. That's all I have for this one. Let me know what you think. I know that I didn't go in too many details, but I'm tired, and the next contest is in about half an hour, so I need to kind of regroup myself. But for complexity, like I said, this function, the combination of this digits minus always goes down by 1, so this will only take number of digits in combination in this as well, and each of those cores only takes up to O of 10, right? There's a for loop of 10, for loop of 10, and technically you could have just divided the math here as well. You don't need to subtract, so you can actually do things in a little bit smarter way, but I usually don't, because these functions may depend on other things. In this case they're all equal, so that's why you can. And here, I think hopefully this makes sense, right? This is the number of digits used and the prefix, and if you follow along here, then it makes, that's why I didn't elaborate too much, because it's the same idea, except for now we're counting it, of the prefix, right? So, and the way that I always say, if you want to visualize this, definitely, and you need to, you want to understand this, just kind of put in numbers, right? So if my max n is 4157, and our current prefix is, which is digits used, as well as 2, which means that our current prefix is 41, then that means that if the current digit is, say, a 1, then all the XX are possible, and you could see obviously how many numbers there are, though you have to do it recursively, because it's not just like, from 00 to 99, because it also, you have to add in the emptiness, right? Because this actually implies 411, 4110, 411x, all the 10 of them, and then now 41xx for the 2-digit ones, right? So or 2 more digits one, so that's why I get a sum here, and that's what this thing does. If it's larger, so this is a case analysis, if it's larger, right, so if you have 1417, in this case, well, all the numbers with 2 digits is going to be wrong, so you only have 1 digit, so it gives you 417 and 417x, and that's it. That's why you have digits left minus 1 with the get or count. Otherwise, if you have 415, which match exactly the prefix, well, then you have just basically 415, and then you do a recursion on 4156, right? And that's basically the idea, right? Of what I wrote here, which is why you have a +1, -1, and they depend on each other. You could have written it like n minus whatever to get the other one, but I just kind of wrote this way to be a little bit easier to write. But yeah, that's basically the idea. And then once you count all that, and the +1 is for the 415, and then once you get all that, then you're able to do this thing. And this thing is basically the bucketing thing that I have here, right? The idea here is that one at a time, you count how many things are in, let me use a different color real quick. You count how many things are in this bucket, and then if this goes over, that's why you choose this bucket, and you zoom in, and then you try again 1 digit at a time. That's basically what, so I have 2 functions for that. One is this get under, which is the prefix is the same, and then you have get every, which is the prefix is not the same. So yeah, and then you kind of keep track of k in that way, and that's basically it. Yeah, that's all I have for this one. Let me know what you think. Thanks for watching, and yeah, stay good, stay healthy, take good mental health. I'll see y'all later, and take care. Bye bye.